All right, in this video, we're going to talk about how to add and subtract rational expressions. Now, as I make this video, I am already assuming that you know how to find a common denominator. That is a key and important part to this process. If you think back, way back to elementary school, when you learned how to add and subtract fractions that have numbers in it, the first thing you had to do was to find a common denominator. And that's true when we do fractions that have variables as well. So if you haven't already watched the video on how to find a common denominator, you want to go back and do that lesson before you do this one. But if you know how to find a common denominator, then the rest of this process is relatively easy. It's not short. It's not even necessarily simple as a whole, but the individual bits and pieces, when you break them up, they're not too bad. All right, so with that encouraging introduction, let's take a look at our learning objectives and we will get started. Only one learning objective in this video, just simply be able to add and subtract rational expressions. And you can see here, in case you had forgotten, when we're talking about rational, really what we're talking about is fractions. That's what we're talking about, rational fractions. These, as far as our class is concerned, we're using those two words as if they're synonyms, right? When we say something is rational, that means it is a fraction. And in our case, specifically right now, it means it's a fraction that has a variable somewhere in a denominator, okay? So with that said, let's take a think back or look back at what we did back in elementary school. So if this was elementary school and I wanted to add together, let's say I've got something like 1/4, and I want to add it to 1/6. Okay, if this was elementary school, then the first thing that your teacher would have told you is you need to make sure that the denominators match. You have to have a common denominator. In this case, those do not match. So because they don't match, what we had to do was we had to find a common denominator. So off to the side, I would do a little scratch work. We talked about this in the last video on common denominators. When it comes to numbers, usually what we do is we just make a list of all the different multiples of that number until we find a number that's in both lists. That's not right. There we go. Sorry, I forgot my times tables for a minute there. All right. So in this case, if we're working with a 6 and a 4, there's my number that's in both lists. That's my common denominator. So we're going to take this expression and rewrite it. Now, all of that we reviewed in the last video, but here's where functionally we start getting into some new stuff. When we rewrite this, we need to have our denominators match. So we're going to use this common denominator of 12. That's our goal, is to end up with a 12 in the bottoms. Okay. So what I need to think about is, how do I take a 4 and turn it into a 12? Well, the way you get 4 to 12 is you multiply that by 3, right? And how do I take a 6 and turn it into a 12? Well, the way you get a 6 into a 12 is you multiply that by 2. So this is basically the process that I'm doing in order to turn my denominators into 12s so that they will match. But another thing that you will remember from elementary school is that if all you do is multiply the bottom of a fraction, that changes its value. And remember, our rule for working with expressions is we can never let the value change. So what we actually do is we multiply the top and the bottom by 3. Okay, now think about why we do that. We know a little bit more about math now than we did back in 3rd grade. Why do I have to multiply the top and the bottom by 3? Well, again, it goes back to this idea that I never can let the value of the expression change. And what's 3 divided by 3 equal to? Well, it just equals 1. So all I'm doing is multiplying 1/4 by 1. And 1/4 times 1 still equals 1/4. So the value of this fraction hasn't changed. But because I'm multiplying the top and the bottom by 3, what happens is I end up with a fraction that has the exact same value, but it looks different. And that's the key to working with expressions. If you've caught on to that, as we're getting towards the end of our unit on expressions, the key with expressions is we're not changing the value, but we're changing the way they look. And so I'm going to do the same thing with this fraction. I'm multiplying the bottom by 2. I multiply the top by 2. That way the 2's would cancel out and I'd have no change in value. But because I'm not canceling them, I'm going to actually multiply. I end up with a fraction that looks different. Okay, so this was our basic process in elementary school. Once we got that common denominator, now all we had to do was just add the tops. I've kind of run out of room here. Maybe I can squeeze it in, but 2 + 3 = 5. And so that would be my answer. Okay, now that basic process that you did in elementary school, it's the exact same process in high school when we work with variables, except for this. And in the last video, we talked about how this process, when you're working with variables, has to be different. So again, if you haven't watched that last video, you want to do that, because in this whole problem, the only thing that's different when we mix in variables is the way we find our common denominator. All right, so there's our first example, something like we would have done back in elementary school. Let's move on now to something that's like a high school problem. So here's example number 2. Example number 2. And I'm going to start with this first example with something that's very small, short, basic type of thing. And then from this problem, we are going to, from this problem, we're going to write out a procedure. We're going to proceduralize this process. Okay, so I've got a 1/x plus a 3/2x. A 1/x plus a 3/2x. Okay, so the process is the same. The first thing I want to do is check to see, are my denominators the same? Are my denominators the same? Okay. If the answer was yes, we would be good to go. We would just simply add together the top. In fact, I'll do an example of that here in the example video, in a few minutes if you watch that. But in this case, they are not the same. So we will find the common denominator. And this is what we talked about in the last video. When we do that with variables, we don't just simply write out these things. What we do is we write factorizations. Well, in this case, they are factored, okay? This is like a 1 times x, it's just an x, 2 times x. If you want to put in the parentheses, you can. If that helps you to visualize it, you can put in your parentheses. But what we said was our common denominator needs to be something that represents all the bits and pieces. So I'm going to need a 2. I'm going to need an x. I don't need another x because I already have an x from this one. So my common denominator is just simply going to be a 2x. And so there is my common denominator. Okay, so that's my first part. And again, the other video goes through that in more detail, a little slower. So if that seemed weird to you, if you're confused by that, go back and watch the other video. All right, now let's go back to our problem. So the first thing I did was I found a common denominator. Once I had that common denominator, then I had to multiply the top and the bottom of my fractions to make that denominator. Okay, so here I currently have an x. I need a 2x. So if I just take x and I multiply it by 2, that's going to give me a 2x. But if I do it to the bottom, I have to do it to the top as well. So in the bottom, x times 2 gives me 2x, and the top, 1 times 2 gives me 2. Okay. For my other fraction, I need a 2x. I already have a 2x. That means I didn't need to do anything. Or you might say I multiplied by 1 if you want to. Okay. But if I do nothing to the bottom, then I'm going to do nothing to the top also. So the 3 that was in the bottom, the 3 that was in the top stays in the top because I didn't really change that fraction. Right. Now, just like we did up here, I've got my matching denominators. All I'm going to do is add the numerators. Notice the denominators stay the same. That common denominator that I had right there, that's still what's in my answer, is that same common denominator. So I'm just adding the tops together. 2 + 3, that's a 5. And there is my answer. Okay, so this is our basic idea. This is our basic idea. Let's go ahead and try and turn this idea into a procedure. So our steps for adding or subtracting, right? Because subtracting is just adding a negative. So it's the same for both. Adding or subtracting rational, AKA fractions, expressions. Okay. So step number 1, we look to see if there is a common denominator. Okay, that's what we did first. We looked to see if there's a common denominator. Now, before we can get to step number 2, I'll go ahead and just put that right down here. Before we can get to step number 2, we have to have a common denominator. Okay, so the answer to this question has to be yes before we can get to step number 2. So step number 2 is going to begin with, now that there is a common denominator, and then we're going to figure out what we do. So here's what we got. If the answer to this question is yes, boom, we go right to step number 2 because we have a common denominator, life is good. But if the answer to this question is no, then we're going to need to go through a little sub process to make that common denominator. Okay, and we learned how to do that in the last video. I'm going to summarize that real fast here. Factor the denominators. And I'm just going to abbreviate that because we've already done that in the other video. Okay, then once we've got the denominators factored, what I suggested in the last video is functionally the easiest thing to do is just copy all the factors from the first denominator. And then from the second denominator, we're going to copy over anything that's new or anything that's different. And again, I go into detail in that process in the other video. So if that doesn't seem familiar to you, if you're not sure what I mean by any of that part, you're going to want to go back and watch that other video. Okay, so is there a common denominator? If the answer is yes, go to step 2. But if the answer is no, then what we need to do is we need to make a denominator. And those are our 3 processes. This says make a common denominator, make a common denominator. Okay, those are our 3 steps. All right, so once we got a common denominator, what did we do next? We multiplied the top and the bottom of each fraction as necessary to create those common denominators. Okay, so in other words, we multiplied by the parts that were missing. This had the x, but it was missing the 2. So I multiplied the top and the bottom by 2. This was not missing anything, so I just left it the same. All right, but that's what we're going to do once we've got that common denominator, is multiply the top and the bottom of each fraction to make the common denominators, lowest common denominator. That was what we did next. Okay. And once we had that common denominator, we just added the tops together and we left the bottom the same. And that's our 3rd step. Add the tops, the numerators, if you want to be a little more mathematically correct, add the numerators. I don't know why I put an apostrophe. Don't tell your English teacher that I did that. That's wrong. Okay. But add the tops and leave the bottoms, the denominators the same. Add the tops together, but leave the denominators the same. So that's our basic process. And here's a very simple example of how that worked, right? We checked to see are they the same. The answer was no. So we went through our process of finding a common denominator. Then we multiplied the top and the bottom over here to make that common denominator. This one already matched, so we didn't have to do anything. Then we added the tops, we added the numerators, and we kept the denominator the same. Okay, so that's our basic process. In the next video, I'm going to work through several examples of this so you can see exactly how it works, including we'll do an example in the next video where they already match, so we can skip this part. And we'll do some videos where, or some examples where they don't match and we have to go through this part. So if you want to see some examples worked out that are more advanced than this one, then tune into the next video and I'll do that for you. In the meantime, thanks for watching this video. Have a good one.